Hello students, in this video we will learn Newton's three equation of motion which is related to the displacement, velocity, acceleration and time of an object moving along a straight line. We will be deriving the equation of motion using graphical method. Now, if an object is in motion along a straight line, the initial velocity is u, final velocity is v, time is t, acceleration is a, and displacement is s. With these values, we will be deriving the equation. Now, Newton has given three equations. First is, if we find the relation between velocity and time, the equation is v is equal to u plus at. The equation for relation between displacement and time is s is equal to ut plus half at square. And the equation for relation between displacement and velocity is v square is equal to u square plus 2as. Let's now learn to derive these equations by graphical method. Let's start with the first equation describing the relation between velocity and time. Now, the graph here shows the change in velocity with time of a uniformly accelerated object. Now here in the graph, the object starts from point D. So, we will mark it as u, that is, as it is starting from point D, it is the initial velocity. So, our point D will be the initial velocity, that is u. The velocity keeps increasing and it reaches point B in time t. So, as it is reaching point B, here the B is the maximum, that is called as the final velocity. So, we will mark it as V, that is the final velocity. Then T is the time which was required. So, now from the graph we know that OD is the initial velocity, that is from here it is starting, it will be the initial velocity, and OC will be the final velocity, that is V. And our time is T, that is OE. Now, we all know the acceleration is the change of velocity. So, let's put the formula for acceleration here. Acceleration is change in velocity upon time. Which is final velocity minus initial velocity upon time. Our final velocity here is OC and initial velocity is OD. So, OC minus OD upon T. If you will subtract OD from OC, that is, if you will cancel this part from this OC, what we will get is CD. So, only CD is left. So, OC minus OD is CD. And we have taken T on the right hand side and CD we have sent on the left hand side. So, CD is equal to AT, that is acceleration into time. This is our first equation. Now, look at this graph. We all know that two sides in a rectangle are equal. That means these two sides are equal. That is BE will be equal to OC and OE will be equal to OB. We will concentrate only on this part, that is BE and OC or CO. So, now how BE is made? BE is made of AB plus AE. So, BE is equal to AB plus AE. Same way how OC will be made? OC will be made up of CD plus OD. So, here what we get is V is equal to CD plus OB, as OC is nothing but V. We have already found out that OC is equal to V. So here we have put the value, that is OC is equal to V. V is nothing but the final velocity, is equal to CD, that is CD plus OD. Now V is equal to CD. We have already found out that it is AT, that is acceleration into time. So we will put here that V is equal to CD, which is AT, and OD is equal to U, that is the initial velocity. This also we have found out earlier, that OD is the initial velocity U. So we will just put the values here. So CD we get from here, that is 80, and OD we get from here, that is U. So V is equal to 80 plus U, or you can also write it as V is equal to U plus 80. So this is our first equation, and this was the first equation given by the Newton. So V is equal to U plus AT is the first equation of motion, and here we have found out the relation between velocity and time. Next is the equation describing the relation between displacement and time. Now, an object with uniform acceleration A has covered the distance s with time t. So, from the graph, the distance covered by the object during time t can be calculated by finding the area of quadrangle DOEB. Now, in the earlier part, we had used the same method. That is, to find the area of quadrangle, we had added two things, that is area of rectangle and area of triangle. So here also, to find the distance, we will add two parts in this quadrangle, that is one rectangle and a triangle. So to find the distance, that is S, area of quadrangle DOEB, that is DOEB, we will add area of rectangle DOEA plus area of triangle DAB. Now, the formula for area of rectangle DOEA is length into breadth, and the area of triangle is half into base into height. So, we will add all the values here from the given graph. That is, area of rectangle is length into base, and area of triangle is half into base into height. Now, as OD is equal to U, so AE will also be equal to U. OE is equal to T, and OE is also equal to DA, so DA is also equal to T. And CD, as we had found in the earlier equation that CD was 80, so CD is equal to BA, so even BA is 80. So we got AE as U, that is initial velocity U, OE as T, and AB or BA as AT. We will put all the values in this equation now. So by putting all the values in the formula, we got S is equal to U into T plus half into AT into T. By this, we will get S is equal to UT plus half, as 2 times T is there, AT square. So this is our Newton's second equation of motion, that is S is equal to UT plus half AT square. Our next equation is the relation between displacement and velocity. Now, we can determine the distance covered by the object in time t from the area of quadrangle DOEB. But DOEB is also a trapezium. So here we are going to find out the distance or the displacement by finding the area of trapezium DOEB. This time we are going to use the formula of trapezium. So, the formula for trapezium DOEB is half into sum of length of parallel sides into distance between the parallel side. So, in this graph, where can you find the parallel side? So, if you will look at this trapezium DOEB, we can find that two sides are parallel. That is, OD is parallel to EB. So, S is equal to half into OD plus BE, as these two sides are parallel, multiply by distance between the parallel sides. Now, what is the distance between these two parallel sides? That is, what is the distance between OD and BE? So, it is OE. So, OD plus BE, that is sum of the length of parallel sides, multiply by distance between the parallel side, which is OE. We will put the values. So, S will be equal to half into, as OD is U, so the value will be U, and BE is V. Now, why BE is V? Because CO or OC was V, so even BE or EB is also V. Multiply by OE is equal to T. So here we have added the values, that is half into U plus V multiplied by T. So we got this equation. Now A is equal to V minus U upon T, that is final velocity minus initial velocity upon T, which is the time. What I can do is, I can send T on the left hand side and A on the right hand side. So, T will be equal to V minus U upon A. So, here I will do, what I will do is, I will add the value of T here now. That is, instead of T, we will be adding V minus U upon A. So, S will be equal to half multiplied by U plus V into, now instead of T, we will add this value, that is V minus U upon A. Then we will get S is equal to, we have just interchanged the values here. Instead of U plus V, we have written V plus U. It makes no difference. Bracket V minus U upon 2 and A. That is 2 multiplied by A. What I can do next is, I can send 2A on the left hand side. So it will become 2AS is equal to V plus U and V minus U. If I will open the bracket, I can multiply V here and then V here. So after opening the bracket, what I will get is V square is minus U square. So 2AS will be equal to V square minus U square. Then what I can do is, I can interchange this both things. That is, V square I will be sending on the left hand side and 2AS I am bringing on the right hand side. So V square will be equal to U square plus 2AS. And this gives our Newton's third equation of motion, which is the relationship between displacement and velocity. So these were the three equations of motion given by Newton. We have learned the three equations. First was V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Thank you for listening, children. Take care. Bye-bye.